This video is going to show you how to identify permanent dipole interactions in any molecule, and then using that information show the interaction on a diagram. Now, I have split it into 3 steps in this easy method. You will need the data book for step 1, and it's page 11 of the data book where you will find your electronegativity values. So here is one molecule. Now, intermolecular forces, which PDPD is a type of, is always between molecules, so not within. Therefore, I need to have more than one of the molecules shown. Now, you could get different molecules, but in most cases you will be asked to show it between the same type of molecule. So I find it easy to redraw it exactly the same to the side and kind of below, or directly below, whatever you've got space for. You'll see why in a wee second. If you draw it right next to it, it can be hard to show that interaction. So step 1, identify the polar bonds using electronegativity values. So in this here, it does say that it's butanal. We haven't learned about butanal yet. It's similar to things you've seen before, but as of just now, you will be shown how to draw it. So for this here, you will see it's similar to a hydrocarbon, where it has carbon to hydrogen bonds. It's got quite a few, and it's got carbon to carbon bonds. Now, prior to this section of the unit, you were told that all hydrocarbons are treated as non-polar and therefore non-polar bonds. So in this case, although there is a difference between carbon and hydrogen on page 11, we ignore it. So we ignore all the C to H's. We also ignore any, it's the same, so C to C, they can be ignored, which leaves us with just C double bond O. Now, what we can do is double check there is actually a difference and that they are polar bonds. So if we go to our data book, you will see carbon, which is here. You can ignore all this middle section and you're just looking at electronegativity, which for carbon is 2.5. Oxygen, you'll see is not further below, is 3.5. So carbon has the lower number, oxygen has the higher number. Because oxygen is more electronegative, that means electrons are more attracted to it, meaning it becomes slightly negative because electrons are negative. So that's just going into the definition of electronegativity to help you remember which one would be negative and positive. But the idea is the negative one is the higher number. So what I like to do is go to my diagram, find the polar bond, which is the C to the O, and just write in those numbers next to it. So carbon, we're putting in a wee 2.5, and oxygen a 3.5. It can be helpful to use different colours here, just so that you can see what's going on. Now we'll put in my negative and positive values. So my oxygen slightly negative, carbon slightly positive. As long as it's as close to it as possible. You do not need the numbers, but you do need those little signs. Now, it will be the exact same over on the other molecule. Again, can put it in if that's helpful. Now you want to show the interaction. So I've already done step 1, and I've done step 2. Interaction is opposites attracting between molecules. So the positive goes to the negative, negative goes to positive. You only need to show one interaction most of the time, unless it says. So just choose any to show. So again, I would just take a random colour and show the interaction. I usually do it with a dotted line, just because it's easier to distinguish a intermolecular force from a solid bond. It's just a bit easier to see it. So if I do some dots or dashes, and you'll see I'm going for that interaction there, so the O to the C. But you could do that C to that O. You cannot do that O to that O, because that's two negatives. You should not have it going to any of the H's, because that's not the bond we're talking about. So it would be repeated for all types of molecules, same 3 steps. So find the polar bond. There may be more than one, as you will see in another video. Decide which atom is positive and negative within that bond. There will only be one for each. And then match it up, showing the interaction.